Okay, so imagine you're going through surgery. They've got using keyhole surgery, they're going to put some pressure sensors inside your heart. They'll probably put one inside the atria here. They might put another one inside the ventricle here, and then they'll put another one inside your aorta here. Okay, so we look at the three pressure sensors. We've got the one in the left ventricle, we've got one in the left atrium, and one in the aorta, leaving three different coloured traces on our pressure graph. We'll start off with the left atrium, which is the black line, and if you follow along, I'm going to draw over it in green. It goes up and then down here, so obviously something's increased the pressure at the same time that the ventricle pressure has increased as well, in between 0 and 0.1 seconds. It's probably going to be the first stage of the heart cycle, which is the atrial systole. So that's probably going to be atrial systole there. Some sort of event has happened here though, which is unusual. So if I mark this with a blue line, oh no. If I mark it with a blue line here, then you can see that the atrial pressure has decreased, but then it's gone up a little bit as something's happened, and then it's slowly increasing here. If we then think about what must be going on, we look at the left ventricle, so that's this one here, that's the red trace. We see that the pressure has massively increased in the left ventricle between here and here. So this must be the stage of this heart cycle where the ventricles are contracting, reducing the space that's available for the blood, putting pressure onto our pressure sensor. So this one must be ventricular systole. Okay. We then follow along and find the last trace, which is in the aorta, which is this blue line up at the top. So the pressure has been slowly decreasing in the aorta until it meets the red line, and then the pressure in the aorta momentarily increases much higher. So that's obviously where the blood has been moved from the ventricles up into the aorta. So at this event point here, the semilunar valves must have opened. If the semilunar valves have opened, then we know that the atrioventricular valves have shut. So that's the AV valves here have shut. If we then look what's happening on the other side of the hill, pretty much, then this area here, the ventricle pressure is decreasing lower than the aorta, yet the blood isn't running down into it, and that must mean that the semilunar valves have then shut. So the semilunar valves are shutting there, and then if we keep going down, then we end up with diastole here. So in diastole, the pressure in the ventricle is going to be now lower than in the atria, and therefore blood is going to start to flow through into the ventricle from the atria. Well, the atria and the ventricle are both going to be filling with blood, and that's why they mirror each other along this point here. So this part is diastole. I better do that in green. So that's going to be diastole, which is really big. In the exam, if they did ask us a tricky question, they were asking us how many beats per minute this person had, we could work that out using the graph. So if I use another colour and I draw on here, so if we look at one heart cycle, it goes from 0 all the way up to about 0.75. So for one full heart cycle, it's 0.75 seconds. We need to work out the beats per minute. So we need to be 60 beats per minute, so that'd be 60 seconds, that is, divided by 0.75, which is the time it takes for one heart cycle, and that equals 80 beats per minute. I hope that all makes sense and shows you some things you could be expected to interpret. Check out the next video, which is going to be about ECG traces.